Is your PC overheating even with a brand new CPU cooler? Chances are, the problem isn't the cooler itself. It's what's sitting between it and your processor. Thermal paste, thermal pads, or liquid metal? Which one should you really be using? Getting this wrong can seriously damage your components. Today, we're breaking it down simply and clearly, so you know exactly what to choose for your specific needs and never have to worry about your PC's health again. Let's get one thing straight. Even the most polished-looking CPU or GPU surface isn't perfectly flat. If you were to look at it under a microscope, you'd see tons of microscopic valleys and peaks. When you attach your cooler, these imperfections create tiny air gaps, and air is a terrible conductor of heat. That's where thermal interface materials come in. Their entire job is to fill those microscopic gaps, push out the air, and create a direct, highly conductive path for heat to travel from your processor to your heatsink. It's a simple concept, but it's the foundation of all effective cooling. So, let's start with the most common one, thermal paste. This is the go-to solution for a reason. It's affordable, safe to use on almost any component, and incredibly effective for most builds. Whether you have a gaming PC, a video editing workstation, or just a standard laptop, thermal paste is your best friend. It is a non-conductive grease-like substance that perfectly fills those tiny gaps on your CPU or GPU die, ensuring efficient heat transfer. Application is easy as small. Pea-sized dot in the center is all you need. The pressure from the cooler will spread it out evenly. Just remember, it does dry out over time, so for optimal performance, you'll want to clean it off and reapply it every 2 to 3 years. It's the most reliable and user-friendly option out there. Next up, we have thermal pads. These are solid, squishy sheets of thermally conductive material. You don't use these on a CPU or GPU die directly because they aren't designed to fill those superfine microscopic gaps. Instead, thermal pads are perfect for components that have a larger, more uniform surface or need to bridge a bigger gap. Think RAM chips on your graphics card, your M2 SSD, or the MOSFETs and power delivery components on your motherboard. The most critical factor when using thermal pads is thickness. This is where most people go wrong. For example, an M2 SSD might need a thin 0.5mm pad, while GPU RAM often requires a 1mm pad. Motherboard chipsets or MOSFETs might need 1.5mm, and some laptop components can go up to 2mm. If the pad is too thick, it will prevent your main cooler from making proper contact. If it's too thin, it won't bridge the gap, leaving an air pocket and doing nothing at all. Always check the required thickness for your specific component before you buy. Now, let's talk about the king of performance, liquid metal. This stuff is in a league of its own. We're talking about a potential temperature drop of up to 20 degrees Celsius compared to standard paste. It offers the absolute best thermal conductivity because, well, it's a liquid alloy made of metals like gallium and indium. But with extreme performance comes extreme risk. Liquid metal is electrically conductive. If even a tiny droplet spills onto your motherboard circuits, it will cause a short and your component is likely dead. Game over. It also has a specific chemical rule. Never, ever use it with aluminum heat sinks. It will corrode the aluminum and destroy your cooler. Liquid metal should only be used on copper or nickel-plated copper surfaces. This is a solution for experienced enthusiasts and extreme overclockers who know exactly what they're redoing and are willing to take the risk for every last degree of cooling performance. So, how do these actually stack up in the real world? We ran a test on a Ryzen 7 7800X3D, a notoriously hot gaming CPU under a full synthetic load. With a standard thermal pad, which, again, you shouldn't use on a CPU, but we did it for science, the temperature hit a worrying 88 degrees Celsius. With a decent quality thermal paste, that dropped significantly to a much safer 79 degrees. Upgrading to a high-end paste like Thermal Grizzly's Kryonaut brought it down even further to 73 degrees. And then there's liquid metal, which achieved an incredible 62 degrees. The numbers don't lie. Liquid metal is the performance champion. But look at the difference between a high-end paste and liquid metal. For the massive risk involved, that 11-degree gain just isn't worth it for most people. For over 90% of users, a good quality thermal paste offers the perfect balance of performance, safety, and price. Alright, let's put it all together so you know exactly what to use for your setup. For a standard gaming PC or workstation, just use a good quality thermal paste on your CPU. It's simple and effective. If you're upgrading or cleaning your graphics card or installing a heatsink on an SSD, you'll need thermal pads for the VRAM and memory chips. Remember to check the thickness. For laptops, you'll often find a combination is needed. Thermal paste for the CPU and GPU, and thermal pads for the surrounding chips. And if you are an extreme overclocker chasing world records and you understand the risks, liquid metal is your tool, but proceed with extreme caution. For any beginner building their first PC, stick with thermal paste. It's the safest and most forgiving option. Choosing the right thermal solution isn't about following trends or just buying the most expensive product. It's about understanding your hardware's needs to ensure safety, optimal performance, and long-term reliability for your PC. Get it right, and your components will thank you with cooler temperatures and a longer lifespan. If you want to dive even deeper, I've created a complete thermal guide PDF. It includes a detailed thickness chart for popular GPUs, my personal ranking of the best thermal paste on the market, and a step-by-step guide for applying liquid metal safely. If you want it for free, just comment thermal guide down below, and I'll send it your way. Thanks for watching, and don't forget to subscribe for more PC tips.